So now that we've talked about the different types of reactions, we know that there is one called the single replacement reaction. In the single replacement reaction, you are to find an element and a compound. They're going to create a new element and compound. You will be predicting whether this reaction will or will not occur using a provided chart. So let's look at some of the details. In a single replacement reaction, an element reacts with a compound. In this reaction, the element displaces an element from the compound and takes its place. It can only do this if it is more reactive than the element it is replacing. Metals replace metals and nonmetals replace nonmetals, with the exception of hydrogen. Hydrogen will behave as if it were a metal in this series. An activity series is a list of the elements placed in order of their reactivity in a single replacement reaction. The higher they are on the activity series, the more reactive they are, and the more likely they are to replace anything below them on the activity series. Activity series can be written vertically, which means the ones at the top are the most active, the ones at the bottom are the least active, or horizontally, in which case the ones on the left are the most active, the ones on the right are the least active. And in this class, we're going to look at two different activity series sets. The first one will be the metals plus hydrogen, and the second one will be the nonmetals, but it will only include the halogens. We won't be looking at any of the other nonmetals for this class. And again, for the single replacement reactions, they will occur if the element reacting is more active than the element being produced. And here's the activity series for the metals and hydrogen. Here you should be able to see that the ones at the top of the chart will replace the ones lower in the chart. So potassium will replace a sodium, and sodium will replace a calcium. So given the reaction between potassium and calcium chloride, I would see that I would end up with a product of calcium plus potassium chloride. You will not be asked to predict what the products are, but I will show you later how you can decide if the reaction does occur or does not occur. And on the test, you will be provided this list if it's necessary. Our second set includes the halogens. And again, here we have the more active nonmetal will replace a less active nonmetal. And we see that fluorine is the most active of the nonmetal halogens, and iodine is the least active. And so we're going to see that this follows the same pattern as what you would see on the periodic table. I do not usually provide this to you because it is the same as the periodic table. The metal one, there's no way for you to recognize which one's going to be higher on the list than the other. But on these ones, they're pretty straightforward because it follows the periodic table for the halogens. So, in this case, if I have a fluorine element plus sodium chloride, I would end up with sodium fluoride plus chlorine, the element, because the fluorine replaces the chlorine. Next, we're going to look at a series of different equations to see how these reactions occur. For these single replacement reactions, we're going to have a metal replacing another metal. So in letter A, we see iron and copper 2 sulfate, and the products will be iron 2 sulfate and copper. How do we know what elements to look at to decide does this reaction occur? So the elements that we're going to be looking at are iron and copper. You can either look at iron and the copper in the copper 2 sulfate because we know the metal is listed first, or you can look at the products and see that the copper is the product, and so we're going to compare those two things. To decide if this reaction goes as written, we need to see that the iron is above the copper on the activity series. So let's look down here, and we see that iron is above copper. And so we know that this reaction does occur, so we'll put a check mark here. For letter B, we're going to look at which two elements. You should be looking at the copper and the silver, and then decide, is the element above the one that's in the compound? And you should see that the copper is above the silver, and so we know that this reaction does occur. For letter C, we're going to look at sodium and what? So we see H2O. What we're looking at in that case is hydrogen, and we see hydrogen bolded down here. We see that sodium is above it, and so this reaction does occur. And the last one, letter D, is zinc and hydrogen chloride, and we see that the zinc is above the hydrogen, and so that reaction also occurs. Notice that we're producing H2 gas on these, And that's what we're going to be observing. So in the next section, we're going to talk about how can you tell if a reaction is occurring. So for that, what you're going to look at are the products. In the first one, you're producing copper, so you should see a copper-colored solid form. In the second one, you're producing silver, so you should see a silver-colored solid forming. And in letters C and D, you're producing hydrogen, which is a gas, and so you should see a gas forming. You should see some bubbles. So those are our signs that a reaction is occurring, and we're going to look at different reactions and see if a reaction occurs. That will tell us which one is above, which metal is above the other. And we're going to use the fact that something is produced to tell us that the reaction occurred, and it will tell us which metal goes above the other, and that will help us to create an activity series. And now we're going to look at a single replacement reaction where a nonmetal replaces a nonmetal. First, you need to recognize it as a single replacement reaction, and that is we have two reactants and two products, and one of the reactants is an element. Remember that the halogens are diatomic, so there's a little subscript 2 there, but that is still the element chlorine, bromine, and iodine. So we can see that both of these reactions are single replacement because they have the element and the compound. And now to decide if it's a metal replacing a metal or a nonmetal replacing a nonmetal, you need to look at the element. In this case, we have chlorine. For letter A, we have chlorine, and so we know that is a nonmetal, so we're going to have a nonmetal replacing a nonmetal. So which is the nonmetal in the sodium bromide? Is it the sodium or the bromine? The bromine is the nonmetal, so that's going to be what's replaced. So the two elements we need to look at are chlorine and bromine, and we're going to compare those, and we need to make sure that the one that is currently an element is going to replace the one that is a compound, so that means that the chlorine has to be above the bromine on the activity series for nonmetals. But notice that I did not provide that activity series for you. So what do you need to do? You need to recall the order of the activity series is the same as the order of the periodic table. You can always have access to a periodic table for all of the tests. So you should see that fluorine is above chlorine, is above bromine, is above iodine, and that means that chlorine is above bromine, and so this reaction does occur. And now let's look at letter B. And we're having bromine reacting with 2 potassium iodide forms 2 potassium bromide and iodine. So our element is bromine, the compound is potassium iodide. We know that this has 2 reactants and 2 products, so it's single replacement. We see that we have bromine, which is a nonmetal, as our element, so that means the nonmetal is going to be replaced. That's going to be the iodine. They're going to trade places, and now we just need to decide, does this reaction occur? So we need to check, is bromine above iodine? So the element has to be above the one that's in the compound form. Is bromine above iodine? And we do see that it is above iodine, and so this reaction does occur. And now I'm going to have you try to use an activity series, and I've provided the one for the metals plus hydrogen. I'm going to have you try to decide if each of these reactions will go as written. So remember, you need to check that the element that is a reactant is higher than the element that's a product. If it is, then the reaction does occur. If it is not, then the reaction does not occur. Please pause your video while you try this, and when you're done, we'll go over all of them. Okay, and welcome back. So let's look at letter A. For A, we have tin and calcium chloride make calcium and tin 2 chloride. The two elements we're going to compare are tin and calcium, and here we should see that calcium is near the top and tin is near the bottom. So that tells us that this reaction does not occur. For letter B, we have copper and water form copper 1 hydroxide and hydrogen. And again, we're going to look for the two elements. In this case, our two elements are copper and hydrogen. And I notice that copper is below hydrogen, so the element that's a reactant is below the one that's on the product side, and so that tells us that this reaction does not occur. For letter C, we have chlorine reacting with zinc bromide, and it forms zinc chloride and bromine. Notice that the two elements are chlorine and bromine, and so that means we're going to be using nonmetals, and we need to use the nonmetal activity series, which is fluorine above chlorine, above bromine, above iodine. So we see that chlorine is above bromine, and that tells us that this reaction does occur. If we look at letter D, we see that we have potassium and water reacting to form potassium hydroxide and hydrogen. And here we see that this reaction does occur because potassium is above hydrogen on the activity series. For letter E, we have hydrogen nitrate and gold react to form hydrogen and gold 3 nitrate. For this one, we're going to be comparing gold and hydrogen. Notice that I don't always list the element first. It can be in different positions. So here we have gold and hydrogen as our two elements. I see that gold is at the bottom and hydrogen is above it, so that means this reaction does not occur. For letter F, we have magnesium sulfate and lead forms lead 2 sulfate and magnesium. Our two elements are lead and magnesium. So lead is just above hydrogen here. Magnesium's up near the top by calcium, and so this reaction does not occur because the element lead is below the magnesium. For letter G, we have chlorine and zinc fluoride makes zinc chloride and fluorine. The two elements we're going to be looking at here are nonmetals, so we need to look at the nonmetal chart. We know that fluorine is at the top, so nothing in the nonmetals will be able to replace the fluoride, so we're going to have no reaction for letter G. For letter H, we have aluminum phosphate and magnesium makes magnesium phosphate and aluminum. And for this one, we're going to be comparing magnesium and aluminum. We're going to find magnesium near the top, and right below that is aluminum, and so we know that this reaction does occur. And for letter I, we have iron 2 chloride and zinc react to form zinc chloride and iron. And the two elements we have are zinc and iron. Zinc is on the reactant side. It is above the iron, right just below it, and so we know that this reaction does occur. And that is the basics of how to use an activity series. Next, we're going to look at how to create an activity series given some lab information. Now let's look at how an activity series might be created. For each of the reactions below, we're going to use the lab observations, which I will be describing to you, to decide whether the reaction occurred or not. Then you'll indicate which nonmetal is more active of the two nonmetals that are here, and then we're going to finally make an activity series from the given nonmetals. First, of course, you have to identify this as a single replacement reaction, which means it has to have two reactants and two products. One of the reactants should be an element along with one of the products being an element. And we see that, for example 1, we have chlorine, which is the element, reacting with zinc bromide, and it forms zinc chloride and bromine, the other element. So the two elements we're going to be comparing in this case are chlorine and bromine. And we want to find out which one is more active. In this case, we're going to take the chlorine and the zinc bromide. In this case, we're going to have the chlorine dissolved in water. It doesn't dissolve well, but it does dissolve a little bit. And then the zinc bromide will also be dissolved in water. These are both clear, colorless liquids. And when we mix them together, an orange liquid forms. Since we see an orange liquid, that means that this reaction does occur. And what that tells us is that chlorine is more active than bromine. We're going to write that as a Cl is greater than Br to say that the chlorine is more active than the bromine. And in the next reaction, we're going to look at it and see that we have chlorine reacting with zinc fluoride, gives zinc chloride and fluorine. Our elements are chlorine and fluorine, and when we put chlorine with zinc fluoride, we see that no reaction occurs. So as we see nothing happening, that tells us that the one on the product side is more reactive than the one on the reactant side. So we're going to put fluorine is above chlorine. So at this point, we can tell that the chlorine is above the bromine and the fluorine is above the chlorine. So our overall activity series at this point is fluorine above chlorine above bromine. So let's go to number 3. We have chlorine with zinc iodide, and it's going to give us zinc chloride and iodine if it reacts. In this case, what we do see is a purple liquid forms. It's dissolving in the water, so it's going to be a purple color. And so we're going to see that that reaction tells us it did occur because we see a color change, and that means that chlorine is above iodine. So far in our activity series, we have fluorine above chlorine, and we know that chlorine is above both bromine and iodine. But we can't tell whether iodine or bromine is more active. So there's nothing yet that tells us that. So we'll have to try some more experiments. The next one is going to have bromine and zinc fluoride making zinc bromide and fluorine. And that reaction does not occur. So we know that fluorine is above bromine. Well, that's no surprise. We already saw that because we had fluorine above chlorine above bromine. So that one didn't really add any information to our test. But we'll go on to the next one. And we see here we have bromine with zinc iodide creates zinc iodide and bromine. And when we do the reaction, we see an orange-colored liquid. That tells us that the reaction occurred, and so that means that bromine is above iodine. And so now we know our activity series is fluorine above chlorine, above bromine, above iodine. And so the most active one is fluorine, and the least active is iodine, as we know already because we taught you that, but I wanted to show you how you could do it with lab information. Our last one, we're going to have iodine with zinc bromide, makes zinc iodine and bromine, and if it occurred, we would see the orange color of bromine, but it does not occur, so we see no reaction, which again tells us that bromine is above iodine. That gives you the basics of how to do an activity series using lab experiments. On the next page, we're going to do it for metals, and then the next one we're going to use the ones that include the hydrogen. Remember, these will be similar to the types of experiments you'll be doing in lab. For this set of reactions, we're going to again be looking at a collection of single replacement reactions, but in this case we're going to be looking at the metal replacing the metal. So we're going to see a slightly different set, and we're going to see which metal is more active. So again, we're going to look at, does a reaction occur, and how you can tell is if you can visually see some sort of thing indicating that the reaction occurred or did not occur. And then we're going to look to see which metal is more active, and then once I have each of those reactivities, we'll make an activity series from all of the metals in this set. Notice that you may already have a chart and you could look at it and know the answers ahead of time, but the idea is to learn how it is done so that during the experiment in lab you know how to set up an activity series with the results that you see. The first reaction we're going to look at is iron chloride plus zinc, making zinc chloride and iron. And for this reaction, we're going to see that it does occur because we see a silvery iron colored solid forming. In fact, this is how galvanized steel works, just in case you wanted to know. The galvanized steel has a coating of zinc on the outside of it, and whenever it gets scratched, the iron underneath can rust. But as soon as it comes in contact with some of that zinc, it goes through a single replacement reaction, and the iron is returned to its original form as the iron element that we would find in the steel. In any case, when we look at the zinc and the iron, we can now see that since the zinc does replace the iron, we know that zinc is above iron on the activity series. So how did I know that this was going to happen with the metals replacing the metals and not the nonmetal? Notice that the element that's present, in this case the zinc, is a metal. That tells us that the metal will replace a metal. In the previous page, we had chlorine and bromine, and the chlorine and the bromine would react, and so we were seeing the difference between the two nonmetals. Here we're looking at two metals because one of the elements is a metal. In the next page, we're going to see some things with hydrogen, and hydrogen will behave like a metal, and so you'll see it replacing metals or metals replacing hydrogen. For the rest of this set, I'm going to have you do them on your own, and then we'll come back and do the activity series. So for the moment, just decide whether the reaction does or does not occur, and then which metal is more active in each equation. At the end, we'll go back and do the activity series together. Please pause your video now and return once you've done all of these equations and decided which metal is more active. Okay, welcome back. So for the second equation, we have iron 2 chloride and calcium reacts to form calcium chloride and iron. And here we can see that we got some solid silver metal that forms, and so we know that this reaction does occur, and that tells us that calcium is above iron. So for the third reaction, we have tin and iron 2 chloride react to form iron and tin 2 chloride. This reaction does not occur since we see no product, nothing seems to happen, so that tells us then that the iron is above the tin. And now let's look at the fourth one. Here we see we have zinc and calcium chloride makes calcium and zinc chloride. For this reaction we see nothing happens. which of course means that the calcium is more active than the zinc. And on the fifth one, we have tin and copper 2 chloride makes copper and tin 2 chloride. And here again, we see nothing happens, and that tells us then that the tin is above the copper. Okay, now that we know how each of those compare to each other according to the equations given, let's see if we can make a complete activity series out of those. Pause the video while you try it, and then come back and we'll give you the answer. Okay, welcome back. I hope you didn't have too much trouble doing this. So let's start from the top and we'll work our way from there. Let's see, we see that zinc is above iron. Okay, that's good. And the next one we have is calcium is above iron. So that doesn't tell us whether the calcium or the zinc has a higher activity. I'd like to look at one of the other ones and see if we can figure that out. So if you look down at number 4, we see that calcium is above zinc. So right now I would put calcium, then zinc, then iron. And then we'll look to see if there's anything else. Next we have iron is above tin. So it looks like we have calcium, zinc, iron, and tin. And then our last one says that tin is above copper, so we'll put copper at the end. So our overall activity series is calcium is more active than zinc, is more active than iron, is more active than tin, which is the least active is copper for the set that I have. As you can see, there's a lot more in the actual activity series, but that gives you an idea of how that activity series was made. Now the last set we're going to do is going to use hydrogen, and I'm going to go through that with you because it's a little bit more confusing, and then I'll have you build the activity series on your own. This last set then is going to be reactions between metals and things that have hydrogen in them. We could intermingle it with the ones previously where we looked at the different metals, but this is just kind of focusing on the ones with hydrogen. This is very similar to what you're going to be doing in your lab experiments. Before we begin this, I want to let you know that some of the experiments that are on here have not been done by me or that I've found by anybody else. They were just made up so that you can see how an activity series could work. You will not find them on any common activity series, so don't go looking for it. We'll be making the activity series based on the experimental evidence that we see. Whether it's correct or not is irrelevant. We're just making it on what we see in our experiment. Next, I want to give you an overview of how we're going to be looking at this. The first thing we're going to do is we're going to test various metals with cold water. If they react with cold water, that means they are in the most reactive set. If they don't react with cold water, then they can move on to the next test, which is to use hot water or steam. In lab and in reality, you do not want to put anything that reacts with the cold water into the hot water or steam because it could explode for you. So you make sure that you do not go on to the next step. If it reacts with cold water, it may not be placed in the hot water. So you'll see in my things that it says do not put this in hot water. Next, if it reacts with the hot water, we know that it is in the second most reactive category. Anything that reacts with the cold water or the hot water may not be placed in the acid, which is our third step. Only elements that are non-reactive placed in the acid. Again, we could have an explosion, so you want to be particularly careful not to put anything that reacts with cold water or hot water or steam. You cannot put that in the acid. So the ones that do not react with cold water or hot water are tested with acid. If it reacts with the acid, we'll put that in the third most reactive category. If it doesn't react with cold water, it doesn't react with hot water, it doesn't react with acid, then it will be in the least reactive ones, which are things that do not react with hydrogen at all, so they're less active than hydrogen. Now those will be ranked dependent upon their activity series that you would have seen in the previous section where we were just looking at some metals. One of the reasons that these reactions are used so often is because it's very easy to find water and because the product is hydrogen gas. That hydrogen gas is easy to spot, and so it makes it easy to tell if the reaction is occurring or not occurring. Furthermore, it tells us how quickly it's occurring by the type of reaction it has. Essentially, if it explodes, that's pretty reactive, and that gives you a clue that the one that exploded on contact with water is more active than one that just bubbles a little bit. And then, again, we can look at how fast it's bubbling. So if it bubbles really rapidly,
we know that it is more active than a metal that bubbles just a little. We will be using the rate of evolution of gas, what we call bubbling, to determine which of the metals within a grouping are more active. So let's get started. In lab, you will also see an additional test that is done, and that is for the ones that react with water. They will produce a metal hydroxide that will make the solution basic. So you will see the litmus test for those. We will not be looking at that in this video because we're focusing on the rate of the gas formation, the hydrogen gas formation. So we're just going to skip over the formation of the base, although it is important reaction. We won't be focusing on that for this video.
In this case, we're going to be making an activity series for 7 metals plus hydrogen. Normally in lab, you'll actually see these as separate charts, but I put them all into one chart so it's a little bit easier to look at. For each reaction, we're going to observe it for about 5 minutes, and we're going to write down what we see. If there's no reaction, I'm going to put an X in the box that said there was no reaction. And if there is a reaction, I'll put a check mark and then write what we saw. So whatever observation we have, did it form some bubbles? Did it turn colors? Whatever it did, we're going to write that in the observation column. Then for each of the ones that do react, we're going to rank them, deciding from the observation which one is more active. After that, we'll go to the next step, which is to add heat. We're going to heat it up until it has steam. We'll see which ones do react. We'll rank them in order from the ones that do react. The ones that don't react are going to be allowed to go on to the next step, which is to add acid to them. And again, we'll rank any that do react with the acid once we have that. And then the last thing is to look at the ones that don't react with cold water, hot water, steam, or acid, and try to rank those in order. And finally, we'll put this all together and we'll add hydrogen into the activity series. So first we place each of the metals in cold water and let it set for 5 minutes. Immediately, we see the rubidium with water explodes. So we know that that one is very rapid reaction and very reactive. Then we notice that the francium is also bubbling. And so we start to see some bubbles forming, gas forming in francium. None of the other ones seem to have any bubbles even after 5 minutes. And so that means that the two most reactive ones are the rubidium and the francium. Now let's rank those, and we can see that one of them explodes and the other one just bubbles rapidly. I would say that an explosion is far more active, so we'll put that as our number 1. And our number 2 will be the one with francium. So rubidium's number 1, francium is number 2. So we'll place an X on all of the other ones. And now for the next step, we're going to see which ones can I add to the hot water. Notice that I cannot put the francium or the rubidium in hot water. I do not want to do that because they could really explode and become quite dangerous. So we'll put an X on those two. Nothing. They will not do any more reactions. We're done with those two. Now we place it in hot water. Actually, we're going to hold it in steam to make sure that it does or doesn't react. We're going to hold each of the metals in the steam for a few minutes, so 4 or 5 minutes. And in this case, we see that only one of them reacts, and that's the one with molybdenum. We notice that there are a few bubbles on the surface of the metal, and so we know that this reaction does occur, and it's the only one that reacts. So this is going to be our number 3 on the activity series, because it doesn't react with cold water, but it does react with steam, so that puts us at number 3. None of the other ones react, so we cannot do the acid test with rubidium, francium, or molybdenum. Those are not allowed to go to the next step. Again, we could have an explosion. We don't want that to happen. So now we're going to take the palladium, the americium, the lawrencium, and the zirconium and place those in acid. We're going to put it in HNO3. That's going to change the equation. So we'll write the new equations here. But notice that we're still forming hydrogen gas. So we're still going to be looking to see, do small gas bubbles form? Do they rapidly form? Do they explode? We'll look at that rate to make a decision on how it reacts. And in this case, we see that only the palladium and the zirconium do react with the acid. And we see that zirconium bubbles rapidly form. And we see in palladium that the bubbles slowly form, small bubbles slowly form. So that tells us that the zirconium is more reactive, more active than the palladium. So we're going to put zirconium above palladium on the activity series. And again, these are still going to be below the one with hot water, which is molybdenum, and even that below the cold waters ones, which were rubidium and francium. So at this point we have rubidium is number 1, the most active, francium is number 2, the second most active, molybdenum is number 3, the third most active, zirconium is number 4, the fourth most active, and palladium is number 5, the fifth most active. So we're still left with americium and lawrencium, and we need to place hydrogen into this system. So it ends up that because the last two do not react with hydrogen, even in its acidic form, those are going to be below hydrogen. Everything that reacted with hydrogen up above are going to be above hydrogen. So we're now going to have the same activity series, but we're going to put hydrogen next. At the last part, we have to figure out how can we tell the difference between americium and lawrencium, and the only way to do that is to do one additional reaction. To compare these two, we're going to keep one of them as an element and the other one will become a compound. It doesn't matter which one you pick. I happen to pick americium and lawrencium acetate, and we write that the reaction will form lawrencium and americium acetate. Again, we don't know if this reaction will go. It's just one of the ones that we could have. If it doesn't react, it tells us one thing. If it does react, it tells us something else. And in this reaction, we do see that a green liquid forms. I'm assuming that that means there was a reaction because we saw a color change. So that means this does react. And that tells us that the americium is above the lanthanum. And those are the last two in our activity series. That means our complete activity series has rubidium as number 1, francium as number 2, molybdenum as number 3, zirconium as number 4, palladium is number 5, hydrogen is number 6, americium is number 7, and lanthanum is number 8. I hope that gives you a good idea of how to do an activity series from laboratory experimental results.